I'm watching on YouTube too. Oh God, they're going to see this now. Okay,
Yeah.
So I'm just going to act like we've started until I see it appear on YouTube. Yeah, I'm nervous. I've never used this StreamYard before, so I want proof that it's actually streaming on YouTube.
It does.
There we go. I see myself. Okay, and I hear myself. That's bad. Okay. Hey guys, welcome to a new live stream. It's the second live stream of this week already. And this time we're doing a MakerCast. And maybe you caught last time, if you're in the Discord, I posted links and stuff like that I was joining the MakerCast. And the MakerCast is a sort of video podcast idea where makers, about 6 of them each month, come together on the first Sunday of the month and they talk about their projects they've been working on and all kinds of other stuff that's been keeping them busy, basically. And it can be anything from woodworking to electronics or PCB design and, well, all kinds of things. So we've gathered 6 guests today, and, they'll introduce themselves once we switch over to them. And, it's just going to be 1.5, 2 hours, we'll see, sitting down, talking about fun projects. And I see some celebrities are here, like Bit Looney. Of course, he's throwing butter into the stream immediately, because, what else? Oh, that's not the right one. Right button. Okay. I'm supposed to also be preparing a quiz, which, of course, all hosts ever forget, including me. So I'll be working on that later. But I'm going to hit it off. For the people who are new to my own channel, who knows? Maybe there's new people. I'm Quindor from Intermit.Tech, and I've been doing videos on YouTube for a few years now, often centered around LEDs and stuff like that. But I also do some server content and other related technical content I like to work and do stuff with. For today, however, this is supposed to be showing off projects you've been working on. So let me switch the cameras here. And I've been working on these boards, and I'm hoping to release them pretty soon. This was an earlier prototype, and this is the newest prototype. I'm actually waiting for some different components to make another prototype, and I'm hoping it's then going to be ready for release. But what these do, and specifically this variant, here you can see a switch. Because, as I said, I do a lot with LEDs, and a lot of you will know my controllers, like this is a Quinn LED Dig Quad, for instance, to run 4-channel LEDs and digitally addressable LEDs. And I did a lot of design optimizations to basically make them run as best as I could make them run. And one of those things I did is that I used my scope and practical testing to figure out the best way and the best resistance to run your data signal from your controller to your LEDs. Because the signal, it's an SPI-based signal, if that means anything to you guys. It's just a single data line signal, so it's not a differential signal. It's not really meant to traverse long distances, but because we want to keep our LED controllers inside, but want to have our LEDs outside, especially for like Christmas lighting and things like that, the data length of the length your data wire can be becomes more and more important. So I did a lot of scoping on that and figured out the ideal resistance, and my current controllers use a 249 ohm resistor. But then it turns out I did all my tests using dual wire, so stuff like this. So you have your black and red, positive and negative power wire, and then I just add a little bit of other wire for the data. So the 249 resistor that's in all my boards is ideal for that, and I've made data signals go 15, 20 meters without a problem with the current setup. But then the new boards came out, and some people reported, hey, your previous boards, I could have a longer cable than I can do with your current boards. What's going on? So, of course, I did a lot more testing, And it turns out that if your power cables are not of the 2-wire variant, but are of the 3-wire variant, where it's basically 3 wires in the same mantle, and basically your data wire is close to ground for most of the way, or for the distance, a capacitance effect happens, where basically, in layman's terms, the ground will start eating away on the data signal because it's close to it over distance. And while I don't have the scope information to show you here, there will be a dedicated video about this at some point. But it'll deteriorate the data signal the longer the cable gets. Now, the way around this is by actually changing a single resistor on your controller, but then again, not everyone likes to solder and stuff like that. So I've made a little board which takes in the data signal, or this side, I'm looking in reverse, and then it goes through a level shifter, so it boosts the signal again. So if you have long wires, it'll also work with boosting. You can do some power injection using these terminals, which will take an M3 screw. And then there's a little button on here, which you can switch to determine what type of cable you have connected, and basically optimize the data signal for that cable. So even if you don't want to solder, this is a project I'm working on to do several things. As I said, to do power injection along the line, and you don't have to solder, to boost the data signal if that's needed for long cables, and to basically condition the data signal to the type of cabling you have connected. So this was an earlier prototype. This is a successor of that. And as I said, I'm working on an even newer ones, waiting on components for that. And this is very new and still a work in progress. And so far, the results look good, but it's not ready to be released yet. And as I said, there will be videos I'll make about this and showing the effects and the scope graphs and stuff like that. But I thought I'd share the project I've been working on and the hows and whys for it. So, yeah. Have you guys ever messed with data resistors on your data line and what it does to your data signal over distance and scoped it out and stuff like that?
So
No.
I'm working now on an audio project, and there you have to do impedance matching and stuff as well. I thought I knew something about electronics. I did not.
That's all exactly my thought. It was like, I did literally hundreds of tests. It's perfect now. And then somebody comes in your Discord, is like, oh, but I use this type of cabling. What? What's going on? Why is everything suddenly different? So, well, as I said, I don't have that much to share right now. Tom, would you like to take over?
Yes, of course. Thanks. So thanks for having me in the first place. This is my first time in MakerCast, so I will do a brief introduction of myself. So I'm Tom. During the day, I write firmware in the R&D team of Ultimaker, the Dutch 3D printer company. And at night, I like messing with electronics. I design some of my own and write some firmware for it and such. And I organize a few events too. And so for today, I thought I would do a bit of a throwback to one of my first encounters with cool electronics, specifically event badges. Now, some of you might know in hacker conferences and such, you have these things called electronic event badges that replace the old paper name tags that you wear around your neck, right? They're now electronic devices, and depending on where you live in the US or the EU, either they look really cool and or they do something really cool. In the EU, we tend to go more to the functional side, and in the US, they're also extremely pretty to look at. So I want to specifically look back into in time to 2017. Where I joined my first ever Dutch hacker camp called SHA 2017. And at the entrance of SHA, I got pressed this little device into my hands. So this one here, I scavenged. There used to be a e-ink screen on top here. And this badge was simply amazing, I think. It contained an ESP32 on the back. It was one of the first to contain it. And the team behind it, badge.team, they called themselves, they wrote firmware for it and opened everything. The thing runs Python, MicroPython, and they made this really nice API. Oh, I see Deshipu has one as well. It's really cool.
Same.
That's really cool, fun to see. Oh, Dave too. Awesome.
Nice, that's cool.
That's really cool to see. So anyway, Dave and Deshipu will know there was an API to program this thing. You could write apps in Python yourself and then upload them to an app store called the Hatchery. And I think during the event, this is a 4-day event, mind you. During the event, I think close to 300 apps got made during these few days. That was just amazing. People wrote games, people wrote viruses, people wrote antivirus programs to counteract the viruses. It was amazing, an amazing thing to have on a hacker event. And so when I left SHA again, I thought, man, this is amazing. I need to do something with this as well. And so I'm in the organization of another Dutch event called CamZone. That's where I know Quindor from, actually. And so the year after SHA 2017, in 2018, I decided we needed a badge too. And together with some other ones, I made this Cyber Kong. It's the first ever electronics badge I helped design. And this thing was super fun. It has Arduino Nano on the back. And it has 433 megahertz radio frequency transmitter and receiver on it.
I only remember toying with the radio all event long.
Man, it was so nice. In the Netherlands, we have this system called click aan, click out, which I guess every country has their own version of it. And it's to operate garage doors and lighting in homes and stuff like this. It all runs on 433 megahertz. And back in the day, there was no protection scheme running on the protocol or something. So when someone was broadcasting, you could listen to the commands they were sending and then replay them yourselves. So this CyberKong badge has this functionality. You can listen to commands and then save them and replay them later on. And the same goes for infrared. So it has an infrared transmitter and receiver on there. So you can learn commands from remotes and replay them afterwards. So we made this for CamZone. We made 125 of them, which in terms of hacker conference numbers is a rookie number, but for us, it was a heavy one. This is the project where I learned to prototype before you go into production. You will see if my camera picks it up that here below this LED there's a small bodge wire, a horizontal one. So it turns out that the Arduino, or rather the Atmega chip on the Arduino, has a few analog inputs that have built-in pull-down resistors and a few that do not. So I used one of the ones that do not. And if you connect a button to it and try to read this button, when there's no pull down and the button is not pressed, the signal goes all up and down. So we had to hack this thing horribly. We had to make it from normal positive to normal ground to improve the signal a bit, and then make all kinds of weird hackarounds in firmware to make it workable. So in the end, we had to rework 125 of these things by hand, and it was just an amazing process. So we learned a lot from this. But then the next year, we wanted to do something cooler.
Yeah.
And this escalates very quickly. So I thought I want to make something that's actually useful after the event, right? That's also the same idea that badge.team had for the SHA badge. We want things to not disappear into drawers here and there, but rather we want people to be able to use them at home. And so I figured what would be useful to have at home? Well, a display that's connected to either your network or the internet. You can display anything you want on there. And that's how the CamZone 2019 badge entered its life. So this is an LED matrix, 256 RGB LEDs on there. Also, like the SHA badge, powered by an ESP32. Like the SHA badge, in fact, it uses the firmware from the SHA badge. programmable in MicroPython, connected to their store. You could write a bunch of apps for them. And so this was a huge step up from the CyberCon, right? It didn't. I didn't just slam an Arduino on there, but now we had a really decent PCB that we had to make ourselves with an ESP32 on there, and all the bulk of the work we had to do ourselves. It was a 4-layer PCB, which was a first for me as well. And we added this fun gimmick on it. Some people will recognize that the white stuff on top of PCBs, silkscreen, you can play a visual trick with it and dither it. So this means to make very small dots on there and differ the distance between them to make a picture. So we have a Nyan cat.
That's freaking cool.
Yeah. So we have a Nyan cat on the front. You can see it here. And there's a picture of NASA on the back of the space shuttle. I hope they don't mind. I think it was royalty free. I'm quite sure. So this was really cool. You can actually see a few of these in my background. On the right on the stream here, I have 4th of July fireworks for our friends in the US, and on the right there's a Nyan cat image. So that was just an amazing project to do, really cool. But then after the event,
I still use that badge sometimes. It's awesome.
That's really cool to hear. So after the event, people asked us, where can I get one? And we had to say, we made enough for the participants of the event. We don't have any extras. I'm sorry, there are no extra ones. And we got this question over and over and over again from people, up to the point where we asked them, you can write down your email address here, and if we ever make a new one, we'll let you know. So fast forward 1 year, we made a new one, a new production run. This one, we made a whole bunch more, and we shipped them internationally. So it's the same one as the 2019 badge. Just a few silly mistakes that we made improved, and we figured every new badge that we make, we want to make cooler, right? So on the previous badge, we had this dithered grayscale art. Well, one step up, what's cooler than grayscale? Full color art, right? So this is the first ever badge that has a full color art printed on the back, which I can tell you is a huge pain. I have there's a blog post writing about how to do this stuff and how to not do it like we did, so it actually works well. So it's a process where an inkjet printer, a commercial one, like a big industrial one, goes over all of the PCBs and jets them with ink that is dried with a UV lamp. And this is done before the components are soldered, mind you. So just a bare PCB, and afterwards it's reflown. You can imagine if you print a little bit of ink on solder pads, it doesn't want to solder that well again. So our initial failure rate for these things was 50%. Only 1 in 2 worked. Yeah, we learned some lessons, but it looks really cool, huh? Yeah. Okay, so this was a really cool project. This one, if people are interested, they can still order. Actually, it's called the Pixel Badge, and you can get them at pixel.curious.supplies. I think we have 20 of them left or something. So
yeah, I believe all the links from all the people are in the description. So check the video description if you want to get one. They're really cool to toy with. So
anyway, that's just a side trip. I want to share one more thing if we still have time.
Yeah, you got a few minutes left.
Good. So 2019 passed. 2020 came along. Of course, we had the pandemic. Things were not going as we wanted. But we did have another camp zone, not a physical one this year, but a virtual one. And we figured, well, we want to make a badge for camp zone again, right? But it has to be cooler than last year. And last year's, I'll admit, I think it was pretty rad, pretty nice. What more can you do than a whole bunch of LEDs on your badge? And we came up with a whole bunch of LEDs and silicon keys. That's better than a whole bunch of LEDs. So this one, the badge for ChemZone 2020, it's a Swiss Army knife, I have to say. So it has an ESP32 on the back, but also an STM32. And this STM32 performs a bit of magic for us. So the ESP32 is again programmable, of course, in Python, MicroPython. Again, hooked up to an app store. You can write for it whatever you want. And the STM32 provides sort of USB magic. So we have it emulating, of course, keyboard and mouse, obligatory, but also a MIDI device. So you can use it to play a piano on your computer. And of course, control audio programs like Ableton Live, and you can hook it up to OBS and stuff like this. And it registers as a web USB device. And this, I want to really quickly share with you, because I think this is just the coolest thing ever.
Well, we have to look at that.
Yeah, Joris Witteman came up with this in our team, and I think it's exquisite. Okay,
Let's
so
see here.
I'm sharing my screen now. I hope you can see it.
One moment. Yeah, there we go.
There we go. Okay, so you're now looking at a normal up-to-date Chrome web browser, nothing fancy. The badge is connected via USB to my computer, USB-C. And we can connect via Chrome, don't have to install anything to the badge. And now, instead of talking to a badge over like a terminal, putty, difficult to understand serial interfaces, you can just open it in your browser. What's even cooler, I don't know if you can see this, probably on the top right here. Whenever you connect your badge, you get a pop-up from Chrome saying, hey, you connected this and this badge. If you click here, then you go to the page where you can control it. And if you click this, then it shows you this URL, or it goes to the URL. So what's cool about this, you have the normal terminal that you have when you connect old badges to your computer. So here you can type commands. You can say, I don't know, like system reboot, and it will reboot the badge. I won't do it now because it will lose it will lose its connection. But you can also look at the file system. You can let's see. You can look at the code of certain apps. You can change it on the spot and save it again.
I really like the file system. That's really unique.
This is so neat, right? It makes developing apps so much easier. I really love it. And also, this I think is really cool. The App Store that was available for all badge team badges, we now made available via this web interface. You can just scroll through the list of apps, press install. I want to install this one. And it will write via your browser all the files to the file system on the badge, and you have it installed. And you will see now, I don't know if you remember, but this button was not there before. That's the new app that we installed. I just think this is the coolest thing for event badges, right? It makes it so much easier for people to use it. Makes it easier to learn. People get much quicker on their feet to learn how to program these things. I think it's amazing. Okay, so then one final thing, if Quindor will allow me.
One final thing then.
One final thing. Okay, so we have a bunch of these older badges that don't have fancy web USB yet, right? Something changed earlier this year. I believe it was in May. Not too sure. Maybe March. Google added this new API to their browser called Web Serial. So not Web USB, but Web Serial. And what Web Serial allows you to do is much like Web USB. It allows you to connect to a USB device, including serial devices. So any older device like this ChemZone 19 here, it will present itself as a serial device. We can connect to it here. And exactly like before, we now have a terminal. We can edit files. We can install applications. And what's important here is that this functions on old badges, right? So every badge made so far, all of them that have USB UART anyway, but that's a bunch of them.
Well, all of them have the ESP32.
Yeah, no. So, but yeah, okay, but also, no, actually, all of them. You can
Oh,
make
okay.
one of these web interfaces for any badge ever made that has a serial port on it,
Cool.
which I just think is the most rad thing, right? We can retrofit now all badges in existence with a web interface like this and make it really easy for people to use them. So I really love these things. That's why I wanted to show it to you. I think my time is up, so I will not mention some of the projects I'm working on right now, but maybe we'll save it for another time. So thanks a lot. Quindor, you're muted.
You're
it seems.
muted.
Sorry about that. So we agreed to kind of an order. Clem, Mayor of Makers, are you ready?
I'm certainly ready.
Okay,
Okay, so hello, peoples of the internet. I'm Clem, aka Maya Makes, aka the guy from Element 14 Presents, among others, because we're like a bunch of makers that release electronic projects on a channel called Element 14 Presents. And I want to show you some of the projects I've been working on lately. And one has just been released this Friday, I think. And I have it basically here. So 2 years ago, I made a project about using like a camera like this one, which is a Super 8 from the 70s. Still working.
cool.
And I wanted to put that, I give it new life. Basically, I found a different camera, not that one, in the trash back then. And I just wanted to reuse it. And then I Googled what the film costs, and it's about 40 euros a pop for 4 minutes of film. And then you have to process it, which costs on top. And there are actually still a lot of film enthusiasts using these cameras today. But of course, it's crazy expensive, and I wouldn't go with that cost. So what I did for a project was I tried to make a digital interface for that, basically a film replacement. So instead of the film that you put in here, you put in some sort of electronic cartridge with a sensor inside, and then it would basically turn this camera into a digital camera. I made a very crude prototype back then that worked, but first the camera that I had was pretty bad, so it didn't look great, and also it did stick out of the back by like half the camera's length, so that would just fit in that one camera. But after people saw that project, a lot of people asked if I could make like a real version of that would work in any camera. As you see, the Super 8 was a very common standard back in the day, and tons of manufacturers made cameras that adhered to the standard and that used the same cartridges. So this one, by the way, is made by Oimic in Vienna. The company is now defunct, I think, but those are pretty legendary for quality. The other one was a Canon one, and like tons of brands made some, and they have slight differences. Some have more features than others, but they basically use all the same cartridges, and some load from the back, some from the top, some from the side. So you have to make that device really exactly like the film cartridge. And turns out that it's not very easy to do, but I've done like a part 2 now of that project, and there were several things that have changed since then, because in the original I used a Raspberry Pi and the Pi camera in there, and some neat wires and a relay to trigger the mechanism. And now we have the compute module, and we have the Pi HQ camera that curiously has the sensor has pretty much the same width than the exposed section of film on a Super 8 cartridge, which is a nice coincidence, but the PCB that it's mounted on is like 3 times the width, so you would never get that in there. So this is a 3D printed representation of a cartridge. I used that for prototyping, and I've made everything fit. This is the real thing. So as you can see, there is a compute module on there. eMMC version with Wi-Fi. And if we look inside here, these are the notches that the camera uses to detect the cartridge and know which settings to use. And if we look inside there's a little prism, and that reflects the beam of light up into the camera sensor. So the camera sensor is actually laying flat like that one. So it's same orientation like the compute module in there.
Is there a
through the back, you
close-up
can
of
see
that?
hypo.
I'm sorry
What do
for
you mean a
just. Well, I watched the video because it came out on Friday, and I don't think I ever saw the prism arrangement with the
prism,
camera in there.
The prism is in there. You can see it reflecting a bit.
Yeah,
that's
sometimes, yeah.
Closer. Okay, cool. Very nice.
Yep.
Would
So
never
the
thought
reflection
of,
is the prism. Somebody complained, I couldn't see the prism. Maybe it didn't arrive. It did arrive, and it's in the video. You just have to open your eyes. It's there.
I think I like that comment.
Yeah, it's hard to see. It's see-through. It's a prism. It's a piece of glass, and it's 10 millimeters big. So what did you expect? Yeah, it doesn't have any sort of lenses in there. It's just a prism that just refracts over 90 degrees to reach that sensor and to make everything fit. So the current status of this project is that fits in the camera. It interlocks with the camera itself. The clamping works, so the camera clamps down on the cartridge so it doesn't move anywhere. But when you start recording, the unit browns out. So it works when attached to, like I can kickstart it with a secondary power supply. Then it boots up and does its thing. But when you start recording, it has browning out issues. So I have to redesign the power supply in there. Yeah, that's my next task for this. And I expected the miniaturization for the charging circuits and to make everything fit in there, because I have to put everything at exactly the right place. Like a 1/10 of a millimeter off is like not working at all. And when you have to place that prism at the exact right spot and the camera, then you have like 0 space left for wiggle room for the rest of the device, basically. So it's like a 1/10 of a millimeter proud over that, and that is like too much. So I have to basically squeeze it in a little bit, and it can expand inside the camera. And when you want to take it out, you have to use tweezers. So I need to redesign that a little bit as well. But one thing that is pretty special about this unit in particular is that kind of resin, so this is a resin 3D print, that is my own brand of resin that I have started during that project. So normal resins, like that one, that's just standard 3D printable resin. If you put that in the cartridge, and I will demonstrate this here, then the mechanisms clamp down, and it does this.
Oh.
So yeah, that's normal resin like you could buy on Amazon or somewhere else.
Oh, no.
That's what happens with these 3D prints, yeah. And
Resin everywhere.
Yeah, and the resin that I printed that with, I call it Meyer Makes engineering resin, because that's what it's used for. You can hit that with a hammer and it jumps. So in the video, I have slow-mo shots where I smash one 3D print after the other, and I also smash this material and it just jumps.
That's cool.
So yeah, it's crazy impact resistant. It holds pretty much I think up to 60 degrees C in temperature, so it's really good. And yeah, I'm currently in the works to make that accessible for everybody, because it's a really cool stuff, and you can mechanically alter it. So what I initially used it for was I 3D print stuff like mechanical components or cases or something oversized, and I did through a steel ball at it. It doesn't do anything. You can hit it with a hammer all day. Doesn't do anything.
Cool. That's cool.
So what? Bitlooney made me forget.
Sorry about that.
Yeah. So what I intended this stuff to do is to replace PTG in my workflow. Usually I have to 3D print mechanical components for some prototypes in PETG to make them resilient enough. But I couldn't get the tolerances that I needed for this project, in particular with FDM printing. So I needed to do it in resin. And what I usually do is I print it oversized, and then I machine it down to the perfect fit. So like friction fit or slip fit, whatever you need. So it gets the tolerances right. And then I take the measurements and put them back into CAD. And when I print the next thing, it's like exactly to the right dimensions, or I can machine it from the new CAD file. And usually I've used then aluminium or something else for that. And now with that resin, I can basically make the final parts with resin to a certain degree. Like, it's pretty much, I don't think it's on par, and we don't have the lab measurements yet and stuff, but it's, I think for small batch production, that could possibly replace injection molding. So no need for that anymore. 3D print at home, it works on any of these 3D printers. So I've tested it with 1, 2, 3, 4, 5 machines or so. Works on everything.
In
so
what
even
colors can you get them?
It's clear. So the resin that I will sell is clear. When you print it, it's yellow, and when you harden it, it gets completely clear. So the yellow color is actually the photo initiator in there. So that's needed, that it can react with the UV light. And when you harden it in a curing chamber, like that one behind me, then it stays like yellowish. And when you expose it to broad spectrum UV light, daylight basically, I put it outside for a few hours, and then it gets completely clear. And you can dye it with any of the typical resin colors you like. I may also sell colors, could possibly be, but it's not decided yet. Fine. But the basic resin will be clear, so everybody can color that how you would want it.
It's funny to learn that when you need something, that's often my drive to create something, is when you encounter something you need, but it doesn't exist or it doesn't do what you want it to do. That's often the drive to make stuff yourself, and it can suddenly, like, you're now selling this resin, if I got you right?
Yeah, so I'm in the process. I can't do like the resin science on my own, so I have actually teamed up, of course, with somebody who knows what he's doing. I've worked at a 3D printing company before, and I had some contacts. So they hooked me up with the right people, and I told them what I needed, and they said, that's gonna be hard. But they figured it out, and we now have a second version in the working that is maybe better printable. We'll see, because that stuff is like, it takes some time to flow back where it belongs on the printers, so you have to print it a bit slower, and maybe we can get it to the same printing speeds like other resins.
Yeah, but even if you can't, it has other properties which redeem it, basically. So yeah. But it's cool how necessity creates things, basically.
Yeah. It's not like double the time or anything. It's just a little bit longer. But of course, it would be ideal if you can reach the same speeds. And yes, I will be selling this resin just for 2 reasons. One is to get that myself, and I want that for myself. And to even get it, I need to purchase like a lot of the raw materials. So it wouldn't be a very wise idea to just buy a lot of resin and then keep it to myself. So I will distribute that. And since I started with that, why not make like a full brand, and maybe we get some other stuff also.
Hey, some really big businesses and other things get born out of a really small idea, like, I need this, fine, I'll make it myself, and whatever, no one cares. And then suddenly everyone cares. So who knows? That's cool.
Yeah, it's pretty cool. And I also tried out, it's like a weird experiment, but you can laser cut it.
Oh, okay.
Like, you can make like needle fine. Like, have you ever seen a wire EDM machine where they make like razor thin cuts in steel and stuff? It's like when you put a laser through that material, it's like the same cut like with a wire EDM machine.
Oh,
We can
okay.
make like perfect cutouts.
Nice.
Yeah, so it's like, it was a stupid idea. Somebody said, "Can you laser cut it?" And I thought, let's try. And yeah, works perfectly.
Nice.
Didn't even fume or something, but I don't know if it's safe yet.
Yeah, exactly.
But
Yeah, that might be a thing.
possibly, yeah. So that was my my project for this week, and we had like very strong reactions on that. I posted that in some Super 8 enthusiast groups, and it's like there are two big it's a very divided community. It's like the one of film purists that really feel offended by making anything digital. Like film is film, and film should stay film, and that is art, and don't change anything with that. And then the other side of the community, they just enjoy using their cameras, and filming in Super 8 is really expensive, and they were like, I want to have that thing because then I can use my camera more often and I don't have to spend that much money, and I could film less important stuff with it.
Yeah, and it'll still give
more
it
the fun crew.
Unique look, I think. So, I mean,
you get the look and you can use it for fun and don't have to worry about the film stock.
Cool.
And yeah, you can see it's pretty divided. That's why if I would ever develop that as far as selling that, it would have it must be some sort of Kickstarter campaign or something like that, because you have to really know how many you would sell. I don't think that many people would get one, but yeah, maybe we can make that happen. But first I have to solve the power supply issues, but I got a lot of good suggestions and got pointed to some pretty nice power supply designs that I may use on that.
Okay, cool.
So
we have a few questions. Bitlooney asks, will you continue building your huge resin printer?
I have yeah, which one? I made a few.
I don't know.
Okay, I had a really big one, for those who don't know, that was like a cubic, half a cubic meter, and that worked like shit. And then I made a smaller version on the same principle, but upside down, where the resin floats on water. And I had to put all the electronics way up because it was salt water, just so I don't shock myself when something goes wrong. And that worked better. But I haven't put any more effort into that, because there are now like bigger machines like that one behind me available, the FEP system that doesn't scale well. So that was the initial idea for my build, to avoid FEP foil. But I don't think that it's like the right way to go. At a certain scale, you just switch to laser-based systems. And yeah, so that's not on my focus list anymore. A different idea emerged. Maybe I'm building an SLS printer.
So okay, that's
that
a
could
whole
happen.
different technique, but yeah.
So that's a different thing. And
so
then
there's one more very important question, and it already started the second you came onto the screen. Will you shave your head? Johnny Bergdahl.
I had like really long corona hair up until yesterday, and I did a Twitter poll on what haircut I should get, and the most votes until until the hairdresser began her work was Forrest Gump. So I got the Forrest Gump look now, and maybe as we have like this running gag of real engineers have no hair, for our colleague James the Bald Engineer, and yeah, I will shave my head when I get to do some real engineering, but I'm not an engineer, and therefore I may have hair for a little bit longer.
Okay.
Yeah.
I think that's a good answer. Well, that was all the questions, I think. It's a really interesting thing, building your own printers and then designing your own resin. That's like a whole different ballpark I've ever looked at. But that's really cool stuff.
It's a bit... when you see something really different, check this out.
Hold on.
So, who of you knows what that is?
A tungsten lamp? I don't know.
No, it's not tungsten. It's tungsuram. That's an
Okay.
electron tube, new in box. From the, let me see, 1949.
Wow.
And yeah, electron tubes still relevant for audio applications, science, and some specialized stuff. Yeah, and I got a bit into tubes over the last years or so. I have
Is this
like
a bit
collection of them.
into?
It's a bit like we have this family thing where everybody starts a hobby and then they get like there's a museum in town that has like most of my father's collection of old stuff, and I've also started like collecting tubes, and I want to build stuff with tubes. Like everybody knows audio amplifiers and like distortion pedals for guitars and stuff like that. Yeah. Awesome stuff. There are people now building vacuum tube based computers, Usagi Electric on YouTube, for example. Yes. And I have maybe obtained like 500 tubes of cheap types that may be suitable for such a project. So could be that I also build a vacuum tube-based computer, or a part of a computer maybe. And then it occurred to me it would be very good to know if my tubes that I have in my collection are actually working before I start designing something with them, because I have only one or two of one type, and some of them are expensive or could be expensive if they are working. Sometimes it may be better to sell them to buy other project parts, or I just want to know more about them and how they work and stuff. So when you want to measure a tube, you can't do that with a multimeter. You need a tube tester. So you can buy a very old tube tester. Usually the enthusiasts call these Schätzeisen, which means guessing iron, because it's pretty much guessing. They don't really measure. And there's one design by a German engineer that designed his own tube tester. His name is Helmut Weigel, and he did not open source it, but he sells a kit of that design. And maybe some of you have built kits like the RC2014 C80 computer, for example. Maybe some of you know that. That's a pretty neat kit with like 100 parts or so. It takes like a long time to assemble, and it's pretty much that size. Yeah. And I've started building a kit for a tube tester called Rötest, which is basically you build a computer with a tube tester that's connected to your main PC to run some very extensive software with databases and stuff. And I assembled that. So I'm going to lift it up, but I will probably not be able to hold it for long.
Wow, okay. Holy shit.
So, yeah, it weighs a bit. So, yeah, and I don't want to like damage the PCB.
Yeah, you can get that.
This is the main PCB. All these cards are like plug-in modules full of relays, and this thing is like the best you could get in tube testing equipment nowadays. It's like a bomb of 1,500 euros.
It's made from all components that didn't exist when the tubes were invented.
Partially. There are a lot on there that run it. There's a PIC microcontroller on there, for example. Yeah, and yeah, it's
the whole PCB process didn't exist in 1949, not in the way we know it.
Yeah, but you can see pretty early PCB stuff in the 50s and stuff like that.
Sure.
Wire wrapping and some hand drawn. Yeah, but this is like a really extensive kit. What you've seen is 15 hours of continuous soldering.
Oh my god. Okay, well, I'm going to cut you off there because, oh my god. Okay. Maybe this is
So this is the case for it.
Holy shit.
And that came from vintage Wandel and Goltermann test device. So
okay. Don't know those, but yeah.
The right thing for that. So if you want to see that, it will come up on the channel one day.
Okay. So, well, everyone, subscribe to, I believe you're on Element 14, right?
Yes, the
Yeah,
channel is
all
called
the
Element
links again are in the
14%.
description. Subscribe to him to follow, subscribe to Clement to follow his projects. And I think we're moving to Deshipu. I hope he's ready for it.
Okay, hello everybody. I don't really have a YouTube channel, but I do a lot of make electronics projects. I'm a Python programmer by day, and I mostly do CircuitPython things as a hobby. So that's that. I don't really have anything like I feel a bit out of place now.
Well,
after
yeah.
the-
Do you have
to
some
present it.
project you worked on, hardware, software wise, recently?
All right. So yeah, we talked about badges already a bit. So a few years ago, I was trying to design a CircuitPython. Actually, back then it was MicroPython still based badge for Python conferences, basically. And I was testing different approaches. One thing we wanted to have was a display, mainly because we wanted to be able to display error messages to the users, because explaining how to connect to the serial just to see the error messages was too difficult. So we wanted something that would be working out of the box. So I made like a couple of those game console like things with different displays. This one, let me, don't have the battery. Like this one. Oh my god.
Yeah, it might be too bright.
Such a shame you can't see it.
The backlight is excellent.
Kind of hardwired.
It's working.
Yeah, but you can see it's very pretty.
Yeah,
It's like
yes.
an old TFT screen, so black and white TFT. The problem with it is that there is a bouncing ball on it, but you can hardly see it because it's moving. And those displays were very, very slow at updating. Basically, if you had an original Game Boy, you know the problem. Like the things that move basically become transparent. So then I went for something like this, which is an OLED display. And that worked much better.
Even on camera, it works much better.
Yeah. So that kind of worked much better. I had several problems with it. Back then, I was still using the SAMD21 in like TQFP footprint, because I was just afraid of doing QFN stuff. So I needed quite a bit of space there, so I needed to use both sides of the PCB.
Oh, yeah.
And
we all start afraid of QFN, so don't worry about that.
Right,
Yeah.
and the main problem I had, that this battery here that I used, it's a coin battery, the CR3220. It was too little to power it. Back then, at least. Later on, I solved that problem. So I had to use these Lear batteries, which are the same shape, but they are actually LiPo batteries and have 3.7 volt voltage, so much stronger. The problem is, if you want to give such things at a conference, and you want to give to a lot of people batteries that look like standard batteries but have much higher voltage, and actually are LiPo batteries that are a little bit more dangerous than regular ones, it's probably not a good idea. So in the end, I ended up with like a thing that used to standard AAA batteries, and we actually made this. But recently, during the plug, I kind of ran out of projects, and I decided, okay, why don't I get back to this? I basically found this in a drawer, and I thought, wait a minute, I can do it better now. And I decided, okay, why don't I try to minimize the number of parts it has? It's always a nice challenge. You know, you minimize the cost, you minimize whatever.
Sure.
Minimizing the number of parts is a fun thing to do. So I designed this PCB, and so it has several things made out of the PCB itself. First of all, this PCB is just 0.6 millimeter thick, because this is a USB port.
Oh, wow.
Here.
Is that USB-C or what is it?
It says USB micro.
Oh, micro. Okay, yeah.
So I also have a USB-C version of that.
Really? Just on the PCB layer?
It's actually nicer because it has those hooks on the sides. So
I want
So
to
you can
borrow
just-
this trick for sure.
So you just have the traces
it
on
works
the
actually
top and the
better
bottom?
with the 0.8 millimeter board, the USB-C one. For the micro USB, you need 0.6. But because I want this to be like accessible to a lot of people, micro USB is still the better choice, in my opinion. At least you can get cheap cables for it. At least.
Well, USB-C is fairly okay nowadays, but yeah.
Yeah, but still the cables are expensive. And if you are doing workshops and you need to bring a lot of cables for people who forgot their cables,
Okay.
you want to go for the simpler option. So this is the USB port. That's the first thing. I did that before because I made like a visiting card version of this Pew thing. Also used this both for power but then I thought, okay, I can also do the buttons, like those are normal touchpad buttons because the SAM-D21 has a built-in touch, so that's super simple. And incidentally, it has it on 6 pins, so perfect.
Yeah.
And finally, I was thinking, okay, what other part I can replace with a bit of PCB, and I thought, okay, this battery holder here is a pretty large thing. And it's just a mechanical thing, doesn't have any electronics inside of it. So why not make it so that you can, take the battery and put it under those tabs here.
And because it's so thin, the board will flex a little bit?
Yeah, those tabs actually flex if you push them out. And you can put the battery in here. The problem is, this is the first version, like this.
I've never seen that done before with PCB material.
Yeah, so the problem is, this is the first version, and I made those tabs too short.
Okay, yeah.
So they tend to do this.
yeah.
Fortunately,
that's why we prototype. I mean, we all have to learn this.
I was hoping to actually show the new version because I have the PCBs on order and they will arrive tomorrow.
Ah, yeah, of course. Yeah.
It's always like that, right?
Yeah.
So, the thing is, I also left the pads for soldering a regular PCB holder. So I have a version with a regular battery in here as well, where you can just put the battery here.
That's really cool thinking.
Yeah, so this has literally like two silicon parts, the microcontroller itself and the voltage regulator, and the display. And the rest is just passives, just capacitors for the display.
Yeah, can't get away with those.
The power. So
that's nice.
That's all it is. And I also worked a bit on the software side. Yeah, so this is the Pew library, which basically emulates this device. So you can make like simple games on 8x8 screen. Right now, I'm still working on a sprite library for this, so you can have like black and white sprites and make like more interesting games. And another software fix that I did, this is using actually the normal 3-volt battery, the 3220.
Okay.
Turns
Yeah.
out that was a software fix. Turns out CircuitPython by default has the brownout protection enabled, because the Adafruit boards that use a flash chip in addition to the regular internal flash have file system on that flash chip, and that flash chip requires at least 2.8 volts. So they had brownout detection set to that. But if you don't have a flash chip, if you are using just the internal flash, you can go as low as 1.8 volt on this chip.
Wow.
So it was just a question of compiling.
That's a lot of tweaking and optimizing on such a little PCB. That's really cool.
Right, and as a bonus, it turns out that all the other devices that I made that use batteries now have longer battery life. So that's a nice win.
And you're just designing these for fun, or do you also sell them, or what's the idea behind it?
So far, it has been for fun. I do have my Tindy, but it's been in vacation mode for the last 2 years.
That's a long vacation.
All right,
Relatable.
it became like a second job, and it was too much work to do this.
I can understand that.
I do have some, I have this pew thing, those two things. I sell them on MakerFabs.
Okay.
So MakerFabs is basically a Chinese fab, but they also have like a shop where they sell electronics. So they also make those devices and sell them there. And
Okay.
Of this. So that's a nice thing. With this, I'm not entirely sure if I want to make it available. Probably yes, eventually.
Yeah, but these type of boards and projects, that's always a lot of lessons learned. So then if you work on a project later on, or with multiple people, like for a badge or stuff like that, you can bring a lot
exactly.
of experience.
Especially with this battery holder thing, that could be useful in so many other projects that, it's mostly exploration thing.
Yeah, but that's fun.
Fun on the side.
Yeah, sure. I can get that. Cool. So anybody...
the smallest possible.
Wow.
And it has a color display. So that was still back before I went QFN. So this is still a TQFP footprint battery.
Cool.
So that's all I have. Thank you.
Anybody have any questions about these things for Deshipu?
Yeah, I have one question actually. So I understand maybe that you use these coin cell batteries because you can get them quite cheaply, right? So they're nice for workshops because they lower the BOM price. But I wonder if you've also looked at these super tiny LiPo packs that you can get now in China, like the 1 by 1 centimeter ones that have just 100 milliamp hours or so.
So the thing is, I really don't want to ship batteries. So I'm trying to use standard batteries that you can buy in a shop, because I don't want to sell batteries, because this is always a headache. And so either simple AAA batteries, and when I really need a LiPo battery, like here in this robot, I just use a standard one from like vaping devices or something, so that I can just tell people, okay, you buy like this standard battery and use that.
Okay.
Because I really don't want to deal with shipping batteries, with packaging batteries, with getting the batteries that are not like 6 years old and already dying and things like that.
Yeah, I can deeply relate with this. Yeah. For this Camson 2019 badge, it has 18650 lithium-ion cells, so also standard size.
That's the way. That's the best way to do it.
And we did want to order them for the participants, because they're quite common batteries, but still not everyone has them, of course. So
Right,
we
but you
wanted to
can
have
order
one.
them in your country. You don't have to ship them from
So
China.
that was a very important lesson I wish we knew beforehand, because we ordered them from China. And so even though it was a very well-known Chinese manufacturer that ships these things by the millions, we had some shipping issues,
It
completely
takes
unexpectedly.
twice as long, and then an extra 2 weeks, and then a margin of 1 to 2 months extra.
So they were supposed to send it in 2 weeks, and it ended up being held at Belgium border control for a month and a half. So it arrived. I think the box of batteries arrived on day 1 of the event, after it had already started.
So another problem with shipping batteries is that they are actually relatively heavy. So the price that you gain, like the gain you get from buying them cheaper in China, you lose in the shipping costs. Because they are so heavy that you pay more for the shipping.
Yeah, I guess it only makes sense per container or something like that.
Yeah, and then you can just buy them from shops that actually buy them by container.
Yeah, exactly. Yeah, I get that. Okay, Dave, you still look very busy.
I just remembered what I want to point out first before I forget it again.
Okay, well, this is your chance. Point it out now.
So, the first project, well, it's technically the last one that I made this month, but we're kind of looking at it by looking through it. I got myself a Raspberry Pi HQ webcam kit, and just put it together and put on the image that you can. I don't know. There are like 2 or 3 webcam images for the Raspberry Pi Zero and the camera modules that turn it into a webcam. I forgot the name, but I tweeted about it. So if you're interested about that, then you can go to my Twitter.
It's a really smart plug here.
Yeah, I noticed too. But yeah, that was kind of interesting. But the kit was very basic. It had an acrylic, a little cutout for mounting the Raspberry Pi Zero and the camera together, and it was the cable of the camera going to the Raspberry Pi was first 15 centimeters, and it made a big coil, and it went into the camera module right next to the USB cable, and it was all a bit too close to each other. So I basically copied the acrylic cutout first in FreeCAD. That was the first time that I used FreeCAD, and that was interesting. And then I took the Raspberry Pi parts and turned them by 90 degrees. And that way I was able to use a 40 millimeter cable to connect everything. That was kind of nice. So now it's looking very sleek, very well in order.
But is this also the camera we're seeing you through now, or?
Yes. That was the weird second part of my first sentence. But yeah, I'm using it as a webcam, and this is kind of a stress test right now because we're going for a while now, and
let's see if it overheats.
Yeah. Let's just see. I have a 5-volt USB fan pointing at it because there's on the other side there's this big white bright light that gets very warm. So I was expecting for it to get a bit warm, but yeah, so far it's still working, and it looks kind of nice.
I'm just wondering how's that linked software wise? Do you get an RTSP stream you put in OBS or something like that, or?
No, it's using the USB OTG stuff that's on the Raspberry Pi Zero.
So it's just a UVC webcam in Windows, for instance. Yeah, okay. Oh,
yeah. It's pretty nice. And very easy to integrate. I also thought about using it in OBS and then do the virtual cam and share some screens so I can show you a picture of the camera right now. But that didn't work out 20 minutes before starting the stream. So,
So you're showing us your project without showing us your project.
Exactly. But now you get the feeling of how the webcam looks as a webcam, at least. Because
Cool.
it's a bit tricky to find good examples of the camera in just running, because people have bad lighting when they show it, and they just put the thing together and then they show you like how close they can get to their nose and stuff.
Yeah, because if I didn't know, I'd say you're certainly in between like a standard webcam and a DSLR type of deal. So I'm shooting on like a Panasonic mirrorless, and I know Tom has a Sony one, and well, your quality is certainly above normal webcam. So, but lighting helps a lot, of course. So it's always hard to judge, but yeah, it looks great.
I think so too, but I'm using the telescope thing that has a range of, I think, 8mm to way more that aren't interesting, because I'm using the 8mm right now, and it's standing in a shelf like more than a meter away from me. So I have this angle where
it's
I'm
not very wide.
No, it really isn't, and you have to get a 6mm wide angle, I guess, to give more of the space. But I kind of like it and regret that I paid 25 euros more for the other lens now. Oh, well.
David Watts says the frame rate is the only giveaway, but not sure that's it might also be StreamYard and YouTube in between and all kinds of stuff. So what frame rate is it supposed to put out?
I think in 1080p it's 30 frames per second.
30 should be fine. Yeah.
That's still because it's only USB 2, and you're restricted to some frame rates there. But it's still more from the resolution than I get from the Logitech C920. I never managed to make it work in full HD, which is weird, but yeah.
Cool. Let's see if there's any more questions, because that was really quick.
I'm not done. That's the first one.
Oh, don't mind me. Go ahead.
What did you expect?
No idea how to arrange everything. But
okay. I'm just going to lean back. Go for it.
Yeah. I don't know. I just went through Twitter and then I noticed like, oh, right, I worked on that, and but yeah, maybe I can show off one thing that isn't very electronic-y, but I threw together some leftover 3D prints and just glued them on a chewing gum container, and then I got something out of that's looking like that.
Okay.
And it's a little Mac, and I also made a small diorama, but I still have to, I don't know, color it and give it a better look, but then now it can stand a bit better.
So these were just leftover parts, basically?
Yes. I couldn't... Well, that's the point where we get out of focus, and it's a fixed focus for the camera, but there are some little parts in there that are, well, the top part and the bottom part here kind of look the same. Those are test prints. I wanted to automate the, well, it's not curtains, it's the other thing that's coming down from a roll.
Sure, blinds, yeah.
Rolling blinds, I don't know, but yeah, I was trying to fit all the small balls on the chain in there, and I don't think they worked. They might have worked, but I had so many test prints that I couldn't tell which one was the right one, the original one anymore. So yeah, I used those. There are some cheap Lego clone parts in here. These are eyes from an astromech where I forgot to scale down the prints, because I was printing everything in 50%, and of course, at one point you forget that you're doing that, or you forgot to scale it down, and then you end up with 100% parts. And yeah, there are some laser cut pieces that came out of the SX64 Raspberry Pi thing that I made for Element 14, and there are so many little parts there that I don't know, I look at it and I think, oh, right, that's from this and that project. So it's pretty...
Yeah, so besides looking cool, there's a lot of, well, I guess sentimental value in it for you too.
Yeah, yeah. So I'm pretty happy about it, and I had an idea about the color scheme, and then I just did it. Well, the inspiration basically was a trash can that was this kind of green and then a silver top. So I went from there and built something. Yeah, that was fun.
Cool. Similar with my stuff. I've made like little trash bots out of broken electronic components, and that was usually the most popular project on maker fairs for the kids. You always wanted to touch it, and some got stolen, and that's exactly like that. I'm sure people will love that there.
I hope they don't steal it though. Yeah, I don't know. I kind of escalated on buying paints for it, so the idea of recycling something quickly turned into just spending more money into another hobby that I don't have room for. And there's an airbrush spray can waiting to get unpacked, but I'm waiting for the thinner for the paints. And yeah, but I always wanted to try that, but I never cared that much, I guess, to spend the money for it.
So
then I did.
Have you ever tried the tabletop miniature gaming stuff?
Not really. I know there's a huge community around coloring it, and there are lots of awesome YouTube channels that just share their techniques and the whole diorama making.
I was about to recommend the tutorials they have, because some of them like weathering, making it look like metal, and so on. It's really nice.
Yeah, I tried some chipping techniques where you just use a silver pen and then brush on the edges and stuff like that.
I see has one.
Yeah, there's a minifig.
Try to learn that as well, but I'm not good. It's a 3D printed one, not a real one.
Yeah.
So try to learn that.
Very nice.
We'll see.
Very nice. Like these little things that I'm obliged to hold in. No, I don't know if you know the alligator clips that someone made. I'm just so fascinated by the colors, so I had to hold them because that's kind of a highlight of this month as well. They're pink and green and pastel colors.
And what about your watch?
Oh yeah, right. That's also on the list of my projects or mentionable things. I bought a smartwatch, and I call it smart because it has a calculator function.
And I had a smartwatch when I was 12 too.
Exactly. And it's also pink. And it's pretty nice. I don't know. I kind of liked it. I thought about replacing the PCB, but yeah, that sounds like another escalating project, and I think I have enough of those. So yeah, I was just dropping the link to AliExpress, so anyone that was yelling like, "Oh, do a replacement board with a USB something," I was like, no, but you can try it yourself. But yeah, I also have some
really
more
tiny.
You kind of have room in there. I always drop my headphones. It's a bit annoying. I thought I charged my big headphones that don't fall out of my ears. But yeah. Anyways, yeah, that was neat. Bought something cool.
So as far as this PCB goes, Travis Goodspeed has a very nice project, a few years old now, called the Good Watch, where he replaced, I believe, the PCB and the microcontroller in a Casio calculator watch.
Wow.
That
Okay.
runs custom firmware. So this is really cool to check out. It's called Good Watch.
Yeah, that might be an interesting point to start. I've never heard of that project. Good watch.
Cool.
Yeah.
I didn't really see any questions.
I have one more thing.
Oh, damn
Right.
it. I keep thinking you're done.
No. I'm sorry. I have sometimes I have large thinking breaks. But yeah, we were talking about transparent prints,
Mm-hmm.
which is also kind of nice lead into my latest. Yeah, I'm looking into my little. I'm calling it game toy now. Before that, it was called the Lame Boy. But I kind of wanted to move away from that. So the first step was renaming it. And then I added a quick connector and also ordered it in the finally in the correct width of PCB to make the Nokia display fit very nice.
So is this its final form?
It's
You missed
for now.
You missed a final form joke. It's okay. Never mind.
That's true. Maybe I can get some other memes in here, but so I'm not sure who posted it, but there was someone that posted a 3D printed case that was completely clear, and he ordered that from PCBWay. I think they're doing 3D prints now. And then I thought, okay, I have to get one of my designs for the case. I just like to have the PCB on top of the print, and then you only have one shell, and you can skip all the complicated parts with the buttons and the display and just have this kind of look. I think it's clean enough.
Okay.
But yeah, so yeah, I had to order one, and that looks pretty nice that you can. I think it cost me about €8 per piece.
Wow. Okay.
But yeah, it
But
would
is that
be
including
probably
including shipping or without?
Oh, I think it was altogether €30. So I bought two, and technically it would be then 15 per shell, but the price itself was €8 for one.
Yeah. So if you order like some PCBs to go with it and stuff like that, it there goes the headphones.
Yeah. Mm-hmm. Yeah. But yeah, it's also interesting to see the web USB and web serial interface, because I think I also had, well, not me, Deshipu made the display 8x8 matrix. Well, what is it called? He basically has this. Yeah, the Pew Pew is basically an 8x8 matrix, and then you can have some games on it, and he kind of ported it to the Nokia display, and then I was able to play the Pew Pew stuff as well, which was nice. But then also, again, it's an ESP8266 on here, so that's also nice to hear about the web USB and web serial interface, so I can maybe get that going as well. I have too many PCBs now. Shouldn't have bought 20. But yeah, that's how you start to sell things on Tindy, I guess. Yeah. And I think the last adventure that I had in this month was I've never really programmed a SAM or an ARM processor. So yeah, I kind of had to. I wanted to update the firmware on Arturo 182's keyboard featherwing. I'm not sure if everyone knows it.
I've seen it before. Yeah.
Yeah, there's a BlackBerry keyboard on there and the big LCD, and then you can put your feather in here. And I also made another adapter board, but there is a software update that lets you tell if which one of the shift buttons is pressed, and then there was another bug. So I thought it would be an interesting challenge for myself to learn how to program it. And I'm not sure I've really learned it, but I went through the process 2 or 3 times, and finally was able to update the firmware with a lot of help from Arturo. So I have to kind of drop this in here as well. Sorry?
So which programmer did you use? The original one, the J-Link, or the open source ones?
I started with the cheap ST links that you can get for €1 or €2, and then but there was someone else, Woody. Some may know him. He was trying the update of the firmware, and he quickly noticed that you can't easily program some of the SAMD chips with those ST-Link adapters. So then I went into the rabbit hole. That's why the cables are on here. Trying to put another firmware on this ST dongle with another ST dongle to then be able to program the keyboard featherwing. And I have no idea if it worked, because whenever I checked for the firmware, it was via I2C, but I used Arduino and I didn't really know what I was doing. So I always got just FF for whatever I was reading, and I thought I broke something, but in the end I was using I2C the wrong way. So I don't know if I have a reprogrammed ST-Link. In the end, Arturo just told me to buy one of those USB-C new dongles that you can use with a different way to update ARM processors, and then it kind of worked. I hope. The firmware is right, but I don't really know which of the ways worked. So.
And did you use OpenLCD with it? The software side. OpenLCD or something else for the software for flashing it?
It was, I think, DAPIS. I don't really know anymore what it was called. DAPIS?
Okay, never mind.
DAPSIS? Something with DAP in there, and then there was a C and an I and an S, but I don't know the order anymore.
Okay.
I have to repeat the process and do something else, and try to program maybe the Nintendo Game & Watch thing that I bought eons ago, it feels like. But I always wanted to do that, and I always buy stuff where I could do something like that, but I never do. And this year I kind of started to work on my skills again.
Nice.
Yeah. And that completes my presentation.
Quindor, you're muted.
Yeah.
I said I wasn't going to say anything anymore, but then I took it literally. Okay. Does anybody have any questions for davedarko, his projects?
We had one in the chat about that old-looking thingy behind him, but I know it's not old.
Oh, yeah. It's not really old. It's and probably Clem isn't that happy to hear about that, but we canceled the contract.
No.
I got rid of that huge Damocles sword, and there are some it's the middle of the year, so it's the end of some calculations, financial year is over now, so they were like, hey, can you finish it, or should we cancel it? And I'm dragging this along for months, and not.
I wanted to see that video.
Yes, but there were so many complications. So just a quick, what is this thing? It's a 16-step sequencer, and it uses just regular logic chips, the 40 series, to make noises. But I basically go to two 8-step stages, and I want to either just go through 8 and then 8 again, or run to both simultaneously. And I made a PCB, and then I had to I started with 2 8-stages PCBs, and then I made a new one in KiCad that was supposed to just put everything together and then just work, but it didn't. and I still have to find a way to get both the outputs and mix them correctly, because right now the output of one oscillator is mixing into the other oscillator part. So whenever one node plays, the other ones go, and it's just a mess. And I didn't know what to do until I just ripped them apart and was just putting them into a left and the right channel, because everything is mono, and then it suddenly worked. And then I had a starting point again, but yeah, that's also like months ago now. But yeah, but what is it? Is it still a question? Or is that the last question?
And I think it's a new question because they didn't understand what a sequencer is.
Okay, so it just goes to 18 knobs, and every knob makes a different sound. You can, of course, make them all the same sound, but it's kind of finicky because the knobs don't always have the same resistor value. I still have one. So yeah, you go to 16 steps or 8 steps, and it makes beep, 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 beep. Okay, there were some tones in there that were shorter than the other ones, which is not something you can achieve there. Anyway, it just makes noises and repeats them. And yeah, it's a noise machine. And you can get interesting stuff out of it when you play it faster or slower. Yeah. When it works.
When it works. Okay. But this project's kind of canceled then, if I understand you right?
Well, it's on hold for now. So yeah, I still want to get it done, have it just work the way that I wanted it to work to. But the whole thing with having this contract behind me was just, yeah, making me sit there, stare at it, and don't really work on it. So I want, yeah, that pressure removed, and then I can look into it again, and yeah.
Sure, I can
Build up the
understand that. I mean, not every project works out. I mean, it's a thing. Okay, then I think we're done with Dave. Aaron, are you live?
I'm here, yeah.
Okay, let me drag you to the foreground. There we go.
Yeah, I hope the audio is not too bad now.
There's a bit of static, but we'll live with it.
Okay, yeah. Yeah, so I'm Aaron, as mentioned, and I have 2 projects I want to show. And one is it's not made this month or the month before. And I already had a video chat with Dave with it. It's about these e-paper price tags you see everywhere these days. And I always found them very magically in the shops and wanted to know how they work. There are many different manufacturers from them currently, and I did look into a few of them. So, and one I looked very deep into and got the system reversed of the stock software. So the whole firmware on the displays itself, which runs on an Texas Instrument CC1110. It's an SoC with an 868 megahertz RF integrated, and so I looked into the stock base station and reversed it as well. So they have the 2.9-inch displays as well as some other sizes as these 7.4 as an example. And in the end, I came up with an ESP32 firmware with another CC1101 module onto it, and the fitting firmware to run it via a web browser running on the ESP. And I'm going to try to share the screen.
Sure.
Let's see. And it should be that. Don't know. if this is
there we
big
go.
enough.
Yeah.
Looks good, yeah. So this website is fully running on the ESP, and we can activate new displays, which are still running the full stock firmware. And I don't know if you can show the webcam and the screen on one.
Maybe something like
So
this.
like this. Yeah, let's try it. So
Okay, let me try and I can't reverse it. Okay, we'll have to do it like this.
Yeah, we can get it. So I can write a text into a text field and select to which display it should send, and this is then this will generate an image on the ESP32 thanks to Larry Bank. And if I now click on send the text, it will show a bit of debug infos in the second window. And if it's successful, the screen should update in a moment with the new image. And in the background is an algorithm running to make the image very small, or the transmission very small, which was a pain to reverse to get it working. And so now we can also see here the text entered in the input field.
Cool.
And I would tell more about it, but I can't. So the whole project is open source and can be used with this manufacturer. And as mentioned,
so that's a pretty cheap way to make a flasher, basically, because all those components already exist. And that's pretty cool.
So if you can get the screens somewhere, you have or just use the ESP and the RF module and can already start. So depends on the screen price, of course. But and the battery lifetime is about 5 years. So
oh wow,
it's
okay,
very
that's
impressive
pretty good
on that side.
Yeah,
To put them somewhere in your house, and also every screen has a temperature sensor in it, so you can also basically show the temperature by reading it and then sending it again to the display. Just a cheap thermometer.
Yeah. Cool. Okay.
So that project is done basically, and also a few months old, but I never showed it that here.
Yeah, exactly. Yeah, that's fine. That's fine.
So that's one project I wanted to share here, and the other one is it's not so simple to get. Maybe you can make the
I can remove the share. There we go.
Yeah, so this is basically an ST-Link, but made with an ESP32 or also a J-Link.
Mm-hmm.
So the ESP32 here bitbanks the SWD protocol, which is used in basically all new processors like the SMD21, for example. But I used it for the NRF chip series, the NRF 52832 or the NRF 52840, which is mostly used in cheap smartwatches these days. So like, the Pine Time, if someone knows it. And also the AirTag uses an NRF chip. And there was, the limited results found the power glitching exploit of them, which enables to read out locked flash via the power glitching. So by very shortly grounding the voltage rail of the CPU core, it will skip the instruction to lock the reading of flash and so on. So I first started to use the ESP32, no, that way, just to test the power glitching, and then using an ST-Link to read out the NRF, as I played a lot in the past with these smartwatches and wrote the new firmwares for it. So it's possible to run a custom firmware like on the Pinetime or the P8. It's also the more or less known one. And it's always easier to have the stock firmware of the watches to reverse how the display is controlled, how the GPIO is working, and so on. So mostly, mostly the D6 fitness checker, I see, from Maya Makes. So mostly online updates were used to get these stock firmwares, but with the power glitching, it's possible to also just read out the firmware on these smartwatches.
Cool. Okay.
And yeah, what Clem is showing is also a watch with an NRF52. It was the second one I worked on, more or less to a full custom firmware. And there you can see the Cent demo. That's a quite old project.
It's very nice to see how many makers are in contact with their firmwares and projects, because right now there's a temperature Bluetooth sensor module connected to my ESP, and the firmware running on it is it's your firmware. So it was funny to start this tutorial, just going through it, how to connect them. And then there's this line like, oh, also you might want to update the firmware to ATC 1441 or Aaron's firmware to make it go better with the ESP Home stuff. Yeah, that was Oh yeah, right. That's another project that I did this month. I started to integrate all those sensors into ESP Home and home automation stuff. But yeah, that's always nice to see.
Yeah, it's every now and then some connections are made. That's strange. So like Quindor already showed video of the Thermometer, of the cheap Xiaomi custom firmware. And it's
that was a good video, and I hope it drove some people your way too, because you were the creator of it. I just showed it off.
It did.
Nice.
It was
good.
Till now the biggest project I ever published. Somehow,
well, I make use of it every day. So, and I know a lot of people who watched my and your videos do also. So, yeah, that's awesome.
Yeah. It's strange for me because I don't use them at all. I got these. It's another project, it's about these, $4 Xiaomi thermometers with an LCD display, and they have an TLSR SoC inside. And till this project, there was only one guy who ever published anything about the an SWS protocol. It's like the SWD debugging interface. But
there's more people using it.
So this programming interface was never published, and also not by TLSR, by the company who made the makes these chips. And so I was happy to get a real debugging or the real programmer for them, for the TLSR chips. So I started to reverse the firmware of these thermometers. And first I got this just blinking a light and so on. So that was really
another one.
It was a real challenge to get this working. Also because the Xiaomi Home app uses these encryption keys, and only if you supply these encryption keys on connection, you can update the firmware at all. So that was the hardest part to get working.
Yeah.
But that was the part that you were interested in, right? Making the whole thing to make it able to make people able to use it and reprogram it and stuff like that.
Yeah, right. So the updating was the only way to make it available, I would say. I also implemented a UART or a USB to UART converter flashing method, which was also based on the PVVX work on the TLSR chips. So that way, if a thermometer is bricked, it can be revived, but it would not be a good option for everyone to update the firmware by opening every of the thermometers to update them.
Yeah.
So the OTA update is a nice addition.
Yeah. Well, as we can, with the 2 people in the stream are using it, and then lots of people in the chat are using it. So even though you don't use it yourself, it's certainly an appreciated project.
Yeah, I'm happy about it. That it found its way.
Yeah, exactly.
The world, to the people.
Yeah, I think it's nowadays it's a very viable or well-known option if you want to get temperature sensors all around your house, because I don't like running a microcontroller in every room, because you have to update them and reboot them, and they need power and all kinds of crap. And now I just run 3 ESPs, one in my garage, one downstairs and one upstairs, and those collect all the data from all those temperature sensors. And that's a lot better than having like 12 or 15 ESPs all around the house. Just doing it centrally.
It's like a throwaway solution. I would call it myself. So even if you forget one, or the battery runs out and you leave it somewhere in the corner, it's not a huge loss.
Yeah,
set and forget, I guess.
Yeah, correct.
BitLooney asks if I'm selling those. No, I'm not selling those. I'm selling ESP32 boards if you want one, but I'm not selling the thermometers themselves. They're made by Xiaomi. So
yeah, I saw that Adafruit is selling them in their shop.
Oh, really? Cool.
Yeah.
Well, they're neat little things, and with the new firmwares and stuff on there, I think most of mine are still running. So battery is pretty good too. I mean, I think they'll last a year or so. I mean, yeah.
Yeah, and the flashing software, or it's just a web page, an HTML page, which runs web Bluetooth. If we are at web serial and web USB already, so
nice.
that concludes all the features Chrome has.
I even used that page like I think it was yesterday. I was at my hackspace and we were checking out the lock mechanism that we hacked into and then control it via Raspberry Pi. But I didn't know that there's also Bluetooth in there. And it was basically just hacked or deactivated by using 8 profiles on that key, so you don't, so you're not able to connect to it and create another key. That's kind of a weird description of it. Anyways, it was a Bluetooth-enabled key that locks the whole place up, and it was that wasn't something that we kind of wanted. So I was looking into how to deactivating the Bluetooth on the board, and I was poking around, and then I found one trace that was just power for the module and nothing else, which was pretty nice.
Like a smart door lock, or?
Yeah, it's a smart door lock, but we kind of hacked into it and used the button connections to control it with a Raspberry Pi, and then we have the whole thing controlling the door. And there are some cool things that are think they are public, but I still don't want to talk about it too much because it's the goal for the X space.
Understandable.
Yeah, but yeah, I was trying to find out a way to deactivate the Bluetooth, like I said, and then to verify if it's still there. I just used your page, opened up the connect thing, and then I saw in the list that the key thing went away, which was pretty
gone,
nice. Just to have this.
Nice.
I mean, I could have used the MAC, but this was a cleaner list, and it had the MAC addresses as well because I was testing it while also the real one was still installed, so it still was, yeah, broadcasting its IDs and stuff. So yeah, it was nice to have this, just a tool to look into the whole Bluetooth around you,
Yeah.
using it for something else. But yeah, it was web Bluetooth.
The only thing annoying me on this web Bluetooth is that there is a blacklist for some UUIDs that the devices use. For example, the legacy NRF DFU. So Nordic has made their OTA examples, and most of the companies use it. The legacy USB legacy ID is in this blacklist. So the web Bluetooth cannot connect to devices with this UUID, which is pretty annoying for hacking smartwatches or Bluetooth devices, Bluetooth low energy devices. Yeah, so that is one thing to the web Bluetooth part. Yeah. So,
Okay. Well, it certainly made it a lot more usable and approachable for less experienced users. I mean, not having to open something up, like the Tuya hacks that came before it, it really speaks to a lot of people to get the decent hardware for a good price, but then run ESP Home or whatever software on it that they know and kind of trust more, and they don't need cloud, and they won't be locked out in the future, and they're not making money off their data or whatever else shady they're doing, because otherwise I still trying to prevent myself from going on a rant about this, but I still don't understand why they bring out the great hardware, but then lock it down so much that you don't really want to use it anymore unless you can hack it. Just give us the hardware. We'll do stuff with it. Don't worry.
that's a big topic. So,
but they go out of their way to lock it down so that we can't do our stuff with it, and it just sucks.
Yeah,
but
true.
I guess our data is worth money. They want to know what temperature it is in my bedroom because money.
Nobody knows if the hardware would be that cheap if they didn't get the data.
Yeah, true. But I don't know.
Yeah.
Cool.
Okay.
So
back to the SWD project.
Oh yeah.
Oops. Sorry.
No problem. So, where was I? So on this ESP is also running a web server, which is providing a nice interface to reflash the NRF chip and also to unlock or lock it, and as well to glitch it and read out the memory content of the NRF, even if it's locked. And I will try to boot it now. I hope it will work.
It's always interesting.
Yeah. So let's see. That looks good. So if you could share the screen again.
Yep.
And maybe you want to make it bigger as well. So it's also quite a simple design, but we have some different menu options to do or what to do with the NRF connected. And if a valid NRF is connected, an initialization, the SWD interface can be whatever it is called. Yeah.
Yeah.
and it will read the core ID of the NRF and also read some memory regions where some infos are stored of what device is connected. So it will read the size of the flash of the NRF, which part it is really, and also what soft device is flashed on it. The soft device is kind of like an operation system for the NRF chipset, or like an SDK flashed. And that way the memory can be dumped or new files flashed to it with just the ESP. And also I added a function to use the glitching without an oscilloscope, because to read out the locked memory needs to be at a very precise moment in time. It's in the microseconds area. And if I run it now, it should work. That's where the problem starts. I need to connect the pin to the right pin. So if we now get a reading, this is like an oscilloscope graph, we would call it now. And this is the core voltage of the NRF, and we can see it is here at around the voltage is not so interesting, but we can see that here is a voltage drop at a moment, and here we can see where the voltage get down to 0, and that is where I'm glitching in this example now. So if I would change the delay time to 4000, we can see it's on another position then. And what we want to glitch the NRF is to put it at the exact voltage drop area. So there around about.
Okay.
And it should be like this. So the 2060 area, but this can change, of course, from board to board, depending on how much capacitors are on there and how the voltage behaves. So it needs to be searched for that point.
That's pretty nice. Well, you can have the glitch thingy there, but you also have the possibility to work with JavaScript to find that point now, and you have lots of different options through the web interface, right?
Yeah, right. It's it could be automated, but in reality, it happens quite fast. So it just needs this. So by vision, we can see where we need to go.
Right.
So like here, the 2000 area. And if I would now lock the NRF, I just need to think if this would work. I need to...
I'm just fascinated by the options that you get with a web interface and what you can do with JavaScript then. And
it's the whole web server is based on the async library, and it's just the best thing you can do on the ESP32 and also on the ESP8266, as it runs it runs on the core 1, where also the Wi-Fi is running, and this way the main program is running without interruption. And you can see also here the icon is blinking. This is every second a request to the ESP32. So this is happening all on core 1. And it's the async library. I can just only say it's good. So
So Aaron, regarding this glitching, can you explain why it's important to do glitch exactly at the voltage drop? Is that where the NRF has started booting? Or why is that position relevant?
It is relevant because there it will start to read the flash. and
So,
there
so
the
the
flash
voltage
is
drop is when the flash gets activated, or
correct. Yeah. So
Smart.
because it draws a bit more current, and the first thing it reads is the UICR value for the locking, and if exactly that point is skipped, it will also show. It will not work now. So we can see if there is a successful glitch that the voltage drop is not there anymore. So it's I don't know why, but it's then clearly visible that it worked. So yeah, but that is why the voltage drop is there.
Nice.
Okay. Cool.
So
Well, that's a lot of low-level stuff.
yeah,
But it's really
That's
cool
interesting
because
for
a
us.
lot of as we said before, a lot of low-level stuff you did is now being used by people who probably don't understand too much of it, partly like me. But they are using it in their daily lives and using the hardware that made possible. So that's really cool.
I hope
But
so.
yeah, no, it is because otherwise people wouldn't use it. So hey. But I'm going to cut you off because we've been streaming for about 2 hours now, and from what I understood, there is a quiz component involved. And, well, I, of course, prepared this very brilliantly, not. And so I've decided to outsource the quiz to investin.tech.com because they've made a quiz. And I think we should all, including the YouTube chat, do the quiz. And I haven't done it myself, so I don't know if it spits out points or something like that. But you can share it on Twitter, and then we can actually verify the actual result you got, because all the Twitters are in the description. So I'll just paste it in the YouTube chat. Oh, and I'll paste it in the private chat too. So I suggest we take, it's now 0:02 on my clock. Let's take until, I don't know, 0:05 to do this test. And then everyone in the YouTube chat can join and Twitter out the results. And then we can actually see what results we got.
Do we
So-
open it now?
Oh,
Yes,
and by the
yes.
way,
Go, start, do it.
while we are
Oh, we
working-
have until 5 minutes
Yes.
after. Okay.
Yeah.
Okay.
So you have a few minutes. I hope that's enough.
And by the way, while we are doing this, everybody remember to subscribe and like.
Yes, go to the
Ooh.
description. There's all kinds of channels and Twitters and all kinds of stuff there. Subscribe to my channel, subscribe to their channels and Twitters. But you're distracting me from the quiz, Deshipu.
and hit the bell icon, right? That's important on YouTube. I
I
understand.
don't care
Little
about
bell
bell
thingy.
icons. I don't
Whatever
care
that
about
does.
Yeah.
You've
Can you
chosen
be
very
right at the
difficult
first
questions,
question?
Quindor, I have to say.
Yes,
I
yes.
don't think I will win this.
But you can
I
only
don't know.
click
I'm
once.
at question 4 or something like that.
How do you win the first question, though?
Yeah, I don't know. Oh, you cannot change your answers anymore.
No, you can't. You can't click once. That's
I
why
didn't
I
notice
have the
that.
first one wrong, because it just clicked somewhere.
Oh, ever used, not what did you use first? Oops. Okay. I need more time.
Well, I need more time too. Okay, let's give it until I don't know, 7 or 8. And since you can't change the answers, I just don't want people to Google basically.
But this is highly entertaining YouTube content right now. Just us staring at the screen.
Yes,
going,
yes.
I don't know the
But the
answer to
chat-
this one. I
the
don't know
chat
this
is-
one.
The chat is doing it too.
Yeah, that's true. That's true.
Okay, I did it. And I'm 10 out of 15.
Okay.
And the first one was wrong, of course.
These are very philosophical questions too. Huh? One of them is, why is big data important?
Yes.
It's
Why
not.
We just
should I
talked about
care?
this. Because they need to know the temperature in my bedroom at all times. What?
Hey, there's a hint button. Just
What
wait.
is the term for text that automatically continues from one line to the next? What does it mean to uncloud? There we go.
Wait, what?
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 Okay.
Whoa. I maybe should have looked up the answers first
Ooh.
myself.
We get some impressive results over there. 13 out of 15, 13, 13, 12, 12, 11.
Wow.
Ooh.
Okay,
I
I'm not
only
done
got
yet.
10.
I'm not done yet.
No, I just need 3 more.
Text buzzwords
Which
related
of
to-
the following is an important step towards the paperless concept? Getting rid of fax machines.
So do I have to share it now on Twitter?
No, you can just say it. It's like you
Yeah.
can Twitter it if you want or tweet it, but you can
Okay.
also type it in the chat or something like that.
Okay, so I'm 13.
Nice.
So one of the questions is, which of the following is an important step towards the paperless concept? And I'm not seeing the right answer. The right answer being this critical flaw that was found this weekend in the printing service in Windows that all over the entire world made everyone disable their printers.
Yes.
That's not there.
It probably wasn't that.
Probably not.
12 out of 15. Oh, I get the smiley right.
I might actually be worse at
Actually,
this
I
than
think
you
the
guys.
Winky was the first.
13
The
out of
winking
15.
It's
Okay,
just a
I'm going to
normal
hit the
smiley.
submit. I only got 11. What
So
did I
who won?
miss? BitLooney, how can you miss it? Oh, BitLooney got also. Oh, BitLooney also had an 11 out of 15.
Yeah.
Aaron
But
did
we-
really good.
Yeah. Deshipu won.
He did? How many did you get?
13.
Really? You got them all?
Of course he did.
No, I got 2 wrong. One was the uncloud thing,
Yeah.
Yeah.
and the second was
Same.
the PDF reader thing.
But then you got 13 or 15?
Yeah.
13.
Oh, 13.
But
Okay.
15
1
is
3.
a
1-3.
13.
Right. Oh,
Better.
okay.
Yeah, I'm
Because we
sorry,
have Aaron here in the chat who has 14 of 15. BitLooney doesn't agree. Bad quiz. I only got 11. I got 11 too, BitLooney. Come on.
Did anyone else think that it's PHP and not Java that is the most?
Oh, I had
widely-
PHP too.
Oh, that was
C#.
easy. Java is really, really popular.
There's always the advertising when Java was installed with 3 billion devices.
3 billion
Yeah.
devices,
Yeah,
and
that's
2 of
true.
them are
That's true.
2 million of them are not long.
What do you
unused.
what does it mean to uncloud? Was organized cloud storage? What the hell?
Yeah,
Yeah.
yeah.
I don't even.
I had
That's
remove all files from the
made up.
cloud because I
Same.
mean, stupid.
But
Word
who should know
wrapping
the
for-
PDF thing?
I had that wrong.
Should have known that it's not Adobe because it's of course it's not Adobe that came up with the PDF stuff, but you're just
Yeah.
But
Everybody
they did
knows
make up
that.
the
using it
format,
Connected
no?
to it. Yeah.
Well, but
I think it
could
is
have
now.
been
I'm
Adobe
not
that
sure it
did
started
this
that way.
Multi-platform one.
Well, so Aaron is, I think, the highest scorer. He doesn't win a prize or anything, but you know.
Also, 13. I have the
15
same as
seconds
Deshipu.
Nice. Okay. So I see a lot of 13s and a lot of 11s, some 12s. So most people got above 10. That's pretty good.
most. Who didn't?
Well, okay. I'm assuming that people who didn't get above 10 just didn't say anything. It's probably not very far off reality. Oh, okay. Thought about PHP. We all chose PHP.
No, I
But
chose
it's C
Java.
sharp. And
Oh, you
that's-
chose Java? Okay.
Yeah.
And it's C sharp. Same reason. I was,
that's
C,
the
of
next
course
stuff,
it's C.
Yeah, that was intentional when they named it.
Okay, of course, BitLooney got it. Nice. So this is maybe a bit different quiz style than we've done before, but I had this prepared in 5 minutes during the stream, so hope I get bonus points for that. And it was very chat interactive, and
It took me way more time the last time to get the quiz together.
But you had a wig and I mean, your character was flawless. I mean,
And I was off screen for most of the stream.
True.
But yeah.
True. Okay. Well, unless anyone has anything they want to add,
Subscribe.
Like.
Comment below.
Hit the bell.
subscribe, like, hit
Click
the bell
icon.
push
Support
all
all these people on
thumbs up,
Patreon.
down. I don't know where it goes. Subscribe, comment. I don't know. I don't usually yell these things a lot. What? Someone
got a donation.
donated. Whoa!
Thanks,
Help.
Philip.
It's my own admin, but thank you. Great content for everyone. Thanks for all insight and nice projects. Yeah, it was fun, especially seeing. That's what I like about the MakerCasts that I used to watch instead of host. There's a real variety of people, and they all do really diverse things, and it's fun to see other subjects and other fields that you maybe not work on yourself, but still get a little bit of insight into it. So I don't know where the next MakerCast is going to be. As long as you follow all the Twitters linked in the video description, you are sure to see when it's going to be coming up again. And I think we're just going to leave it at that. And I thank everyone for being here and for joining us, for doing the test in the chat. I mean, come on. And I hope to see everyone back in the chat for another MakerCast. So, see you guys later.
Thanks for viewing, everyone. See you around.
Goodbye, everyone.
Bye.
Bye.
And